Hello everyone. In our previous lecture, we have discussed one of the criteria air pollutant, that is ground level or tropospheric ozone, or we can say that the bad ozone. So in this lecture we will be discussing the second criteria air pollutant, which is carbon monoxide. Carbon monoxide. It is not the carbon dioxide, it's carbon monoxide. So carbon monoxide is the colorless, odorless, tasteless and poisonous gas. So in the atmosphere, carbon monoxide is primarily comes from incomplete combustion of carbon based fuels. So in the atmosphere, the carbon monoxide primarily comes from incomplete combustion of carbon-based fuels. So what are carbon-based fuels? It is coal, it is gasoline, petrol, it's diesel, and fuel wood or any other biomass. It could be crop residue. So if there is the incomplete combustion of carbon based fuels such as coal, gasoline, petrol, diesel, fuel wood or biomass, the resultant emission would be carbon monoxide. So it would be carbon monoxide in the atmosphere. So what is incomplete combustion? Incomplete combustion is when any of the following four variables are not kept sufficiently high, then the incomplete combustion results. So oxygen supply is the one variable, combustion temperature, gas residence time at high temperature, and combustion chamber turbulence. So incomplete combustion happens when the following four variables are not kept sufficiently high. The oxygen supply is if oxygen supply is not sufficiently high, combustion temperature, that is if the temperature is below the 600 degrees Celsius, and gas residence time at high temperature, and if the combustion chamber turbulence is not sufficiently high, so the resultant emission would be carbon monoxide. And this process is called as incomplete combustion of carbon based fuels. So these four parameters are generally under much tighter control in stationary sources. So what are stationary sources? Stationary sources are basically non-moving, moving, or we can say point sources of pollution. So what are those? Those are power plants, industries, factories, etc. So these are the stationary sources of pollution. So it is said that in general, under stationary sources or in stationary sources of emission, these four parameters are generally under much tighter control. So if these four parameters are under control, the combustion would be complete. So if the combustion is complete, then the resultant emission would not be carbon monoxide. It would not be carbon monoxide, right? So from the stationary sources such as power plants, industries and factories, carbon monoxide concentration is usually less as compared to motor vehicles. So in motor vehicles, these four parameters are not sufficiently high, and this lead to the incomplete combustion. So incomplete combustion result into carbon monoxide emission. So our 80% of the total carbon monoxide emissions are from transportation sector. So carbon monoxide mainly comes from transportation sector, that is mobile sources. So breathing, if the concentration of carbon monoxide in the atmosphere is high, if we breathe high concentration of carbon monoxide, it will lead to react with hemoglobin. Why? Because of its more affinity towards hemoglobin than oxygen, which leads to the formation of a carboxyhemoglobin and interferes with the blood's ability to carry oxygen from lungs to the body organs and tissues, and therefore it is an SV hexate. So let me explain this graphically or in some simple words. So in the normal process of respiration, we inhale or we breathe oxygen rich we breathe in oxygen rich air, then it goes to our bronchus, then from bronchus it will go to bronchioles, then bronchioles to alveolus, then we have the final distillation of oxygen, that is alveoli. So these tiny sacs are called as alveolar sacs. So basically these are alveolar sacs. In the alveolar sac, the oxygen coming from the air will exchange to the blood, which is basically in the capillary surrounding this alveolar sac. So the exchange of oxygen take place here in the capillaries which are covering the alveolar sac. So in the blood we have RBCs, and RBCs we have red blood cells, that is we have in RBCs we have hemoglobin, and which is basically a iron rich protein. So in simpler terms, hemoglobin has 4 sites to carry oxygen. If the hemoglobin carries oxygen at its 4 sites, then we can say that it is oxygen rich blood. But when carbon monoxide enters the bloodstream from the air, it grabs onto the heme groups. It grabs onto the heme group of hemoglobin and once CO binds to the hemoglobin, it will form a, once this CO binds to the heme group, it will form a stable and complex compound called carboxy hemoglobin, right? Now, if the concentration of this carboxy hemoglobin is high, this leads to the decrease in ability of, or it interferes the blood's ability to carry oxygen from lungs to the body organs and tissues, right? So instead of binding of oxygen on 4 sides of hemoglobin, there will be a binding of carbon monoxide, which leads to the condition of less oxygen in the blood. Therefore, a condition is formed called the asphyxiation, is the condition where there is a reduced supply of oxygen to blood and ultimately to the tissues. So basically, this complex which is formed in the high concentration of carbon monoxide, the carboxy hemoglobin, it interferes the blood's ability to carry oxygen from lungs to the body and body organs and the tissues. Therefore, leads to the condition of asphyxiation. What is an asphyxiant? Asphyxiant is a substance which basically reduce the blood ability to carry oxygen and suffocate and make the condition like suffocation. So this is asphyxiant. So basically, carboxy hemoglobin, a complex which is formed during this process, is a asphyxiant, right? So why carbon monoxide attach to the hemoglobin instead of oxygen? Because carbon monoxide has about 200 to 300 times more affinity towards hemoglobin as compared to oxygen. So this carbon monoxide has 200 to 300 times more affinity to bind with hemoglobin as compared to oxygen. That's why it will form a carboxy hemoglobin complex, which leads to the reduced supply of oxygen to blood and ultimately to tissues, right? So the usual way to express the amount of carbon monoxide in the blood is as a percentage saturation level. So what is the percentage of carboxy hemoglobin in blood? It is the representation. So So it is basically represented in percentage of carboxyhemoglobin in blood. Okay. So it has been studied that a percentage of 1.7%, at a percentage of 1.7%, different types of health effects noticed. So starting point of health effects is basically 1.7%. 1.7% of carboxyhemoglobin. If the concentration of carboxyhemoglobin is 1.7%, it will start the health effects, right? Then at the 10%, headache is common. At the 30th percent, most people experience dizziness, headache, fatigue. And at 60% of carboxyhemoglobin saturation in blood, at 60%, it will lead to unconscious conditions, even death. If the exposure is prolonged. At 60%, if the exposure is prolonged, this will lead to unconscious and ultimately lead to the death. So for this 1.7%, which we have discussed earlier, that at 1.7% the health effects starts. So if we calculate the ppm, parts per million, of carbon monoxide at 1%, 1.7% of 1.7% of carboxyhemoglobin by using the CFK equation. CFK equation is basically Carbon-Forster-Kane equation. So usually we use the modified this CFK equation to calculate the ppm and percentage of carboxyhemoglobin in the blood. If we calculate at 1.7%, this means that about 35 ppm of carbon monoxide is equivalent to 1.7% of carboxyhemoglobin in blood. Okay, so if you compare this 35 ppm with cigarette smoking usually a single cigarette have a 200 ppm of carbon monoxide. So you can imagine how dangerous is cigarette smoking. A single cigarette has a 200 ppm of carbon monoxide. On the other hand, we have said that, and many of the studies said that at the 35 ppm parts per million concentration, the different types of health effects starts appearing. So you can imagine at 200 ppm what will be the result of carbon monoxide, right? So this is the usual way to express the carbon monoxide or the amount of carboxyhemoglobin in the blood. So this was all about the health effect of carbon monoxide. Now carbon monoxide has an indirect radiative forcing effect. Carbon monoxide, other than the health effect, carbon monoxide also has indirect radiative forcing effect. Indirect radiative forcing effect. It has the indirect radiative forcing effect by elevating the concentration of methane and tropospheric ozone by reacting with other atmospheric constituents. So what is basically the radiative forcing, RF? Radiative forcing is also called as climate forcing. कहा जाता है कि कार्बन मोनोऑक्साइड का इनडायरेक्ट इफेक्ट रेडिएटिव फोर्सिंग भी है. So what is radiative forcing or climate forcing? So basically radiative forcing or climate forcing is used to measure the net change in Earth's energy balance. So radiative forcing is used to measure the net change in Earth's energy balance. So what does that mean? What is the energy balance of Earth? Energy balance of Earth means the amount of radiation or energy that is received by the Earth from the Sun is equivalent to the amount of energy going back or emitted by the Earth to the outer space. So if this incoming radiation energy is equivalent to the outgoing energy radiations, this means the energy balance of the Earth. So if this energy balance changes, and this change measure in the change of energy balance is called as climate forcing or radiative forcing. So for example, at the top of the troposphere, at the top of the atmosphere, we have a solar constant of 1370 वाट पर मीटर स्क्वायर. मतलब कि हमारी एटमॉस्फेयर के टॉप पे 1370 वाट पर मीटर स्क्वायर एनर्जी रिसीव होती है, राइट? If this is our solar constant, right? This is our solar constant, that at the top of the atmosphere we are receiving the 1370 watt per meter square of energy in the form of solar radiation. So as we know that Earth is a sphere, then we will divide this 1370 divided by 4, and it will be equivalent to 342 watt per meter square. So out of this 42 watt per meter square, 31% is Earth's albedo. 31% is Earth albedo. That means 31% of this 342 watts per meter is reflected by Earth, reflected back by the Earth. So 31% is basically equivalent to about 107 watt per meter square. 107 watt per meter square. So if we subtract this 107 watt per meter square from 342, it will be equivalent to 235 watts per meter. So this is the net energy we are receiving at the earth. This is the net energy. This is the net energy we are receiving at the earth's surface, which is equivalent to 235 watt per meter square. So the amount of energy, this amount of energy received at the earth's surface should be equivalent to the energy रेडिएटेड बैक टू द स्पेस. अब जितनी एनर्जी अर्थ ने रिसीव की है, एब्जॉर्ब की है, इतनी ही एनर्जी अर्थ जो है वो रेडिएट बैक करेगी स्पेस में. देन द बैलेंस इज इक्वलेंट. अब इसमें अगर बैलेंस में रेडिएटिव फोर्सिंग जो है इट कैन बी पॉजिटिव रेडिएटिव forcing and it could be negative radiative forcing. If the positive radiative forcing is there, that means the earth atmosphere is absorbing the outgoing radiation such as greenhouse gases. If the concentration of greenhouse gases are high in the atmosphere, they will absorb the outgoing radiation and the radiative forcing will be positive. So radiative forcing, positive radiative forcing means global warming. So global warming or the positive radiative forcing is due to the greenhouse gases, the additional greenhouse gases such as carbon dioxide, methane, etc. And if the radiative forcing is negative, if the negative radiative forcing is there, this means that the cooling of the earth takes place. This negative radiative forcing is usually linked with the aerosols. So aerosols has the negative radiative forcing on the earth, and other greenhouse gases such as methane, ozone and carbon dioxide has the positive radiative forcing. So positive radiative forcing means there is a global warming. So this was about the radiative forcing. So coming back to our topic, carbon monoxide has indirect radiative forcing effect by elevating the concentration of methane and tropospheric ozone. If the concentration of methane and tropospheric ozone increases in the atmosphere, what will happen? It will absorb the outgoing terrestrial radiation, which is emitted back by the earth. It will trap the radiation and result will be the positive radiative forcing, or we can say the earth will start warming. So this was the indirect radiative forcing effect of carbon monoxide. So how this will form the carbon dioxide or ozone? It is when carbon monoxide react with oxygen in the presence of energy of Hv gives the carbon dioxide and ozone. So these are both greenhouse gases. So what is the dominant source of carbon monoxide in the atmosphere? The fossil fuel combustion, as we have already discussed in the above section, that when any fuel of having carbon based fuel is burned in the presence of oxygen, it will lead to the formation of carbon monoxide, right? So further it will also comes from the oxidation of methane, also the hydrocarbons oxidation and biomass burning. So these were the health effects and indirect radiative forcing effect of the carbon monoxide. So as I have already discussed, every pollutant has national ambient air quality standard for it. For every pollutant we have national ambient air quality standard. That means we have prescribed limits for every pollutant. That means the concentration of pollutant should be under some limits. So what are those limits? What are those national ambient air quality standards for carbon monoxide? It is 2 milligram per cubic meter. Sorry, 2 milligram per 2 milligram per cubic meter, and 2 milligram per cubic meter for 8 hours, and 4 milligram per cubic meter for 1 hour. So the national ambient air quality standards for carbon monoxides are 2 milligram per cubic meter and 4 milligram per cubic meter for 1 hour and 8 hours respectively. So how it is carbon monoxide, how carbon monoxide is measured in the atmosphere? Carbon monoxide measured in the atmosphere. How is this measured in the atmosphere? It is measured using NDIR method. NDIR method is basically non-dispersive infrared spectroscopy. Non-dispersive infrared spectroscopy. So non-dispersive infrared spectroscopy is basically a method in which the infrared radiations are allowed to pass through a simple cell of carbon monoxide, and the resultant intensity of light is measured. So if after passing the carbon monoxide sample cell, these IR radiations intensity decreases, that means the carbon monoxide is absorbing the IR radiation, and this decrease in the concentration or this decrease in the intensity of the light of the IR infrared radiation is proportional to the concentration of carbon monoxide. So this is basically the simplest way to explain the NDIR method, non-dispersive infrared method for the measurement of carbon monoxide in the atmosphere. So what are the dominant sinks of carbon monoxide? Sinks mean कहाँ जाता है, मीन्स कार्बन मोनोक्साइड इतना जो प्रोड्यूस हो रहा है एटमॉस्फेयर में वो कहाँ जा रहा है. सो द डोमिनेंट सिंक ऑफ कार्बन मोनोक्साइड इज रिएक्शन विद OH रेडिकल्स. सबसे ज़्यादा OH रेडिकल्स जो हैं एटमॉस्फेयर में वो कार्बन मोनोक्साइड को कंज्यूम्स करते हैं. ठीक है. Around 80% of the carbon monoxide is sink by reacting with OH radicals. About जितना भी कार्बन मोनोक्साइड प्रोड्यूस हो रहा है, about 80% of it is sink by reacting with OH radicals in the atmosphere. In the process of where carbon monoxide react with OH radical, then gives the carbon dioxide plus hydrogen. Further, this hydrogen react with oxygen, gives the HO2 radical. Then HO2 radical react with NO, gives the NO2. This is the process of consumption of carbon monoxide by OH radical. Consumption of carbon monoxide by OH radical. So this process of consumption of carbon monoxide by OH radical is about 80%. So 80% of the carbon monoxide is consumed by OH radicals in the atmosphere. So if you see the global estimate of OH radical consumption by different pollutants, this was about the carbon monoxide consumption. Now this is about the OH radical consumption. The OH radical consumption is about carbon monoxide out of total OH radicals in the atmosphere. Out of total OH radicals in the atmosphere, carbon monoxide consumes about 40 to 50%. Methane consume about 15 to 20%, and non-methane volatile organic compounds consume about 20 to 30%, and hydrogen consumes about 5 to 10%. So this is the global estimate of OH radical consumption by different pollutants, out of which carbon monoxide consumes about 40 to 50% of OH radical, right? On the other hand, out of total carbon monoxide, about 80% is consumed by OH radicals. So don't confuse with these two terminology. Separate them and try to understand the process. This is basically the consumption of carbon monoxide. About 80% of the carbon monoxide is consumed by OH radical, and inversely, if we see the consumption of OH radical is consumed about 40 to 50% by carbon monoxide. So this is it for carbon monoxide. In the next lecture, we will be discussing the third criteria air pollutant, which is nitrogen oxide.